All right, folks, it is 11 a.m., a little past 11 now. We're going to get started here. If you can please take a seat, either up front or somewhere where you can see the screen. We're just going to get started here right now. All right, everyone. Thank you so much for coming today. Really appreciate you guys coming out the weekend before Thanksgiving. Super excited to see what everyone builds today. My name is Ivan. I'm one of the organizers of Cerebral Valley. We're a community that started out in San Francisco and kind of have been running events, hackathons, developer events all over the world now, and really appreciate Meta bringing us out to Austin. Super excited to see a lot of the talent here is amazing, so excited to activate the community. With that said, I'd love to welcome our partners on the stage, Jake and Michael from AITX. Please give them a warm welcome.
Awesome, thanks, Ivan. I'm also gonna invite up to the stage, our partners at Meta. Do we need to cast slides or? Morning, everybody. How we feeling? Good? All right. There's a little bit of life here. That's pretty good. Again, thank you guys so much for coming out. It's really cool to see the local developer community spending the weekend before Thanksgiving, building cool stuff. And specifically, we'll dive into in a second the different areas that we'll be hacking this weekend. But really quick, want to just quickly introduce myself and AITX. My name's Jake O'Shea. My day job is I'm a venture capitalist. I'm an investor at Antler right here in Austin. So if you're thinking of starting a company, if you've recently started a company, you're looking for venture capital funding, please come find me at some point. We'd love to chat about it. Michael and I started AITX about a year and a half ago. And really the goal of AITX is to bring together the local developer community and the local startup community. So I look out in the crowd, I see a lot of startup founders, I see a lot of local engineers, and I think we're doing a really good job. But that's because of you guys, and that's because of y'all's willingness to come out and engage and participate in these types of events. So give yourselves a pat on the back for just coming out, and I'm really excited to see what you build. If you see on the screen, we've got a QR code. You can sign up for our community directory. We're never gonna spam you, we're never gonna share your information with anyone else, but we do have exclusive events, opportunities. Michael puts together a really awesome newsletter each week that covers all of the coolest AI events and opportunities right here in Austin, but also broadly across Texas. So if you'd like, sign up for there, and we'll be in touch for other ways for you guys to get involved with what we're doing here. Now I wanna pass the microphone over to Michael to talk a little bit about what you guys are gonna be building this weekend.
Hey everybody. Woo. Oh, okay, it's right there. Hey, what's up? I'm Michael. Like Jake said, I'm one of the co-founders of AITX, and I put out the weekly newsletter. And I wanted to talk to y'all about what you guys are going to be building. There are 2 tracks. The first one is the open source developer tooling. Big call out, if you guys do go on this track, there's a $1,000 prize for the best llama stack. And the next area that you can actually build with is the local Austin impact. So there's a lot of cool things you do in Austin. You could target the homeless situation. You could talk about finding your favorite restaurant, anything that has to do with Austin specifically, you can focus on that. Now I'm going to pass it over to John.
All right, good morning, everybody. My name is John Boxtans. I'm an innovation policy manager at Meta, and just wanted to start off with quick introductions from myself and my teammate Amanda. We're thrilled to be here, really thrilled to be partnering with AITX, and love seeing what a huge turnout this morning. So my name's John.
My name is Amanda. Some of you see me yesterday. I sit on the policy team in Meta here in Austin. So excited you guys be here.
Thanks, Amanda. Did anyone here go to the reception last night? Can we give Amanda a round of applause? She was our driving force for that last night. Cool. So thank you. Like we've said, means a lot to us to have the turnout on a Saturday morning here, the weekend before Thanksgiving. I think we had more than 150 people last night at the reception. So it's amazing to see just the level of enthusiasm and the really thriving AI community here in Austin. It's something that Meta cares deeply about, not only because we are building products, but we love seeing how this community can take those products and create value and make a real difference, whether it's in businesses or just making a positive social impact across the globe. And that's why we're not only sponsoring parties like last night, this whole hackathon this weekend, but also wanted to chat with you all about how all of this is meant to be a pipeline for our Llama Impact Grant Program. My role and Amanda's role, we work on a team at Meta. It's designed to help bring to life the value of open source AI. Something that we talked about in the panel last night is that I think it's clear to everyone in this room that there's no technology like AI in modern times that has so much potential to expand economic opportunity, to improve quality of life, and to, I think in many ways, transform and help facilitate education. So not only can AI do that, but when you take an open source approach like we've done at Meta, it makes all of those benefits more accessible. And it's something we're really proud of, and we're really grateful for the work that we're already seeing out there. One of the challenges, though, is as we're thinking about Llama, we know that there's like a huge amount of Llama adoption. There are hundreds of millions of downloads, tens of thousands of variants. But because of the open source model we're taking, we don't always know who's using our models and what the use cases are. And so this grant program, it's not designed to like drive adoption. We know that's happening, but it is a program to help us identify some of the most meaningful use cases around the globe. And this is a program that we've run, already run through a couple iterations of this. So this morning I want to share some of my experience. I was a judge for our first round of grants last year. I was a mentor to help some of the grant finalists along. And so this chat's going to be designed to help you out with that. We've got a few QR codes here. Like one, if you're new to Llama, you can scan the link to learn more there. I have a feeling this group is pretty well aware of that. But I do want to draw your attention to the third QR code at the bottom. That's where you can follow along with the grant application website. I'll give it a couple seconds for some more QR code scanning. And this slide will be at the very end, too. All right, so there's a lot of text here. I think this could be helpful, though, just to like give you a sense of why we're doing this. This is now really like the third iteration of this type of grant program work. Last summer, so not like a few months ago, but like 18 months ago, we launched Llama 2. We were really in that situation that I mentioned earlier, that we knew that there was like this incredible uptake on Llama, but it was important to us to identify some of these meaningful use cases. And that really helped motivate us getting out that program. I will say one of the challenges is like it's a limited pipeline in terms of like the global winners. Of the hundreds of applicants that we got last year, there are only 3 winners for the final prize. So there were 3 grantees who received $500,000 grants. There was one that we gave a $300,000 grant. It became clear to us that there were so many meaningful applications that came in that we wanted to find ways to expand opportunity. So I'll explain how we're doing that with this latest iteration. But another example of this is that we gave away 11 $300,000 innovation awards. And then this latest iteration is now technically the Llama 3.1 impact grants. It got launched before 3.2 went out, but it's the latest iteration. So this iteration is also going to be giving away $500,000 grants, but in this presentation, I'll explain how your participation in this hackathon gives you access to like a special North America track where we've created other opportunities to be able to compete for $100,000 grants in addition to this overall global award. So, like I mentioned, there's 2 parallel tracks here. One, like the top prizes are these, or top grants are $500,000. Some important considerations here is that in this grant program, this is really designed to kind of draw out meaningful use cases using the capabilities of Llama 3.1 and 3.2. I'm going to be followed later by our partner engineering team, who's going to be able to explain like specifically what that means and what we're looking for. But so keep that in mind. And in terms of the preferred focus, this is, again, I'm going to refer to this in a later slide, and I'll come back to this slide. But things that we're looking for, again, showcase the newest capabilities of Llama 3.2, I'd say 3.1 as well. We want to lower the barriers for other developers to build with Llama, and so that's why one of our tracks today is building open source developer tooling. So your participation here, that's going to be very helpful. And then the other consideration is that we also want to be addressing, demonstrating how Llama can make a positive impact for economic development, science and innovation, public services, education and skills development. So we have 2 tracks today. One I just mentioned on the open source developer tooling, that's important. And then the other piece for local impact, if you can address any of those issues, that's also helpful. So again, if like either track can kind of put you in the right direction for this grant program. And that's all under consideration for the $500,000 grant program. And as I mentioned, we also, in parallel, have a $100,000 grant program that is open only to those who showed up at in-person events like this. So this is where y'all have a really big advantage because, I mean, don't quote me on the exact number, but I think we're doing 3 in North America. So this is a very small population, which gives you all the opportunity. Like, you should go for the $500,000 grant, but the $100,000 grant for North America only, and if you're able to show, hey, here's what I contributed for the Austin Hackathon, that gets you into a much smaller stack. And with that, so it must indicate, and I'll show you exactly what this looks like in the grant application. You need to show that you were here. You need to complete the hackathon, which we're all in our seats today, which is great. And yeah, just also the consideration that if you are in this $100,000 track, it doesn't take you out of the running for the $500,000 track, if that's clear. So don't worry that if you're doing this one that you're selling yourself short. This is just a special shorter stack for the North America events. And I'm clicking and nothing's happening. Let's see. If I were better, I would have memorized my slides, so I wouldn't need them. But I do need my slides. Oh. One moment. My Mac is telling me that I need to update, and I'm not going to update right now. Maybe? Rats. We'll be right there. We are going to do this tomorrow. One moment. Thank you, Amanda. Are we? I think we are. Okay. I'm going to say okay to whatever it is that my computer wants. We're going to allow everything. Okay. Holy crap. Okay. We're back. Thank you. Thank you. So, this slide is just showing those 2 parallel tracks that I mentioned. There's one for the open call. The deadline for this, by the way, December 1st. So just short timeline for getting an application in. And the same is true for this regional track. So get your applications in. This is just meant to show that this regional event track is open only to y'all and the other people across the North America events who attended events like this. This is what it's going to look like when you apply. So I think it's pretty straightforward, but it's going to ask you if you participated in a Meta-sponsored Llama event. That's this right here. You should select yes. In this example, it was for Asia Pacific, but you're going to click North America. And then really importantly, they're going to ask you for exactly the name of the proposal that you submitted through this hackathon. All right. Criteria. So this is a little bit of the fine print, but important. I can tell you as a judge of the previous hackathon experience that I read through a lot of these applications, and for each of them, and this is all on the website, it's all in the terms, so it's out there. But I can tell you that when I score these applications, that I have to go through each proposal, and there's a grid, and I have to rate along each of these criteria. So if there's like 6, 7 on here, I have to give 7 different scores, essentially between 1 to 10, to say, how well do they meet these criteria? So like the best score is like you're aiming to get a 10 out of 10. Like you want me as a judge to say like, oh yeah, these guys really nailed it and these gals really like get it. And the more clear you can make it along each of those tracks, the higher your score. So I wanted to talk through what that looks like. The first, very clear, like, are you using Llama 3.1 or 3.2, especially the new features that my colleagues will talk about in a moment. Applicability. With this one, in the application, probably going to have to give some kind of problem statement, or like, what are you trying to do or solve? And with this, it's important that your application has a sign of like measurable success. How do we know if you're like actually achieving what you're doing? So again, just keep in mind measurable, and what are you measuring? The impact kind of goes back to some of what I was talking about earlier, like what kind of difference are you making? And is it something like, this is really, I think, a question of scale too. So if you're like building for local Austin impact, that's good this weekend. But if you have a solution that's also scalable to other cities and other places, that's even better because you can make an even bigger impact. Responsibility, this is just showing that you're being thoughtful about what you're building. So, for instance, and this is very hypothetical, if you had some kind of solution that, I don't know, was like a social security number generator and you like had a repository of people's social security numbers, in technical terms, just don't be an idiot with this. Like, make sure you're being mindful of private information and that you're being, you're taking the right data security protocols into consideration. This is something that, at least my recommendation, you don't have to write a thesis on this, but just show that you're being responsible and that we don't want to award a grant to someone who's going to abuse people's data. And so and also like, don't hurt people with the solutions you're building. Like, just, this is pretty common sense. Technical feasibility, I think, will not be an issue for this crowd. It's honestly why we're doing hackathons, to try and generate interest, is because the first time we did this grant program, we received a lot of very good ideas from very well-meaning applicants who, upon like further investigation, it was clear they didn't necessarily know how to build the things they were trying to build. So in your application, make it clear that you know how, and like give us an explanation that would make sense to someone who is thinking about if you could actually put this into practice. Similarly, is there a business plan? Like, are you building something that has a unique value that doesn't necessarily exist already? So again, another like wild hypothetical here, but if you were trying to use Llama to create the world's like best search engine, that may not be a great business plan because there's like already a pretty dominated space with other competitors. So like, make sure you're demonstrating that you're creating some unique value and that you're thoughtful about like who would use it, where would it be used, and how would you like get from step 0 to step 4 or 5 along the way. So you like could actually put this into practice. And then we're gonna look to see if you're applying against the preferential topics. And this is the slide I mentioned earlier. I'm gonna take a big risk and go back to the slide that I think caused my problems. These are the preferential features on the bottom left of this slide. So we talked about it before, but we're looking for it, like, are you using Llama 3.1, 3.2? Are you lowering barriers for developers? And are you making a meaningful social impact with what you're building? And that's it. Whew. Thanks for bearing with me, everybody. I'm happy to take questions, and then I'll be followed by our partner engineering team to help you think about how you can build solutions for today's hackathon and the grant program. So I see one question out there. Do you mean the problem statements for this hackathon? Yeah, I think they do overlap. Let me go back to the preferential or the preferred focus. One of our tracks for today's hackathon is building open source developer tooling. That would fit really well with lowering barriers for other developers to build. And then the other is building for local impact here in Austin. And that is a good example of addressing like economics, science and innovation, public services, education, and skills development. And I'd say like the sweet spot is like if somehow you find a way to like achieve both of those, like that would be pretty great for a grant program. But also, if the grant's not your thing, like and if you want to be very specific on Austin, that's great too. Like so, I think they fit well. Correct. Yeah, so it would be one application that you're applying for both parallel tracks. It's just there's a lot more competition for the open call because y'all have this like special opportunity being a very small group of people here and in the other couple of events in North America. Yeah, good question. I think you had your hand raised earlier, but I'll get to y'all in just a moment. So go ahead. I think you do, and I'm sorry I don't have clarity on that answer, but I think that is what they're looking for, and I can get you that. I'll confirm that this morning, but yeah, that's the latest that I had heard. Yes, sir.
So I started filling out the application, and I noticed there's like a word count, and I'm thinking, should I be more concise in the, like, should it be easier to read, or should it be a very well-developed?
I look at, so the question is like, is it important to be concise? And my answer to that is like, just as someone who is like, been a hiring manager before, trying to like hire for jobs, a one-page resume is always better than like a 5-page resume, if that makes sense. Like make it easier on the reviewers to get what you're saying without giving us like a huge reading assignment. And that's why we have the word limits. So it's okay to get, like use that word limit as much as you want, but you're not gonna, like, if you can find a way to like help me understand what you're doing quickly and concisely, it's just gonna make my job easier. I won't be like worn out by the time I read. Sure, totally. So like, be thoughtful about it, but like, you're not going to get extra credit for using every single character.
You can tell Llama, just give me like 1,000 words.
Yeah. Cool, but good question.
Is it possible to maybe resubmit or fix up your application after you submit it, like from looking at the evaluation criteria now?
So if you've already submitted. Yeah, so there's, I guess what I would say, I think on one of these slides, never mind. There's, on the website, there's a like, basically a help at, like, an email. Like, I would email that website, or I'm sorry, that email address, and explain your situation, and I think we'd be able to work with you. Like, I know the people on the other end of that email account, and so, yeah, we'll help you out if you need to adjust. Yes. I mean, this grant program is for Llama. If you're using, it doesn't have to be exclusively Llama. Like although I would say, like, if I'm a judge and I'm trying to like prioritize between two very close applications, I'm probably gonna opt for the pure Llama one. But I don't believe that's in the terms. I don't think it's disqualifying, but in terms of like the criteria we're looking for, like we are looking for demonstrated use of Llama 3.1 and 3.2. Much like the hackathon today, like it's a Llama hackathon, but like what we're most excited about is like aside from the grants, we just want to see what y'all are building, and we want to promote that. Yes. Yeah, I guess the question was like if your solution could be implemented with another model, is that a problem? Like I don't think I would lead with that in the application. but that's like the value of open source. We want to be able to learn from each other. But again, like I want to help you all give us the best possible applications. And like I, as a judge, I'm not going to care how clever your name is for your project. I'm not necessarily, there's a lot of like extraneous things that may seem relevant, but I can tell you these criteria, that is what I'm judging on. And so if there are other models in there, that's not necessarily something to like, it just doesn't fit the criteria. So I'm not even paying attention to that as much as, are you using Llama 3.1, 3.2? I think the most important thing is feasibility, right? So if you want to have a really complex version, or if you want to have different applications of Llama, like I think we really value that diversity. But it's, again, I'm using these criteria when I'm judging. So like if you are, and in particular, the things we care most about are the new features of Llama 3.1, 3.2. So like I would let that guide you. Like the what it is, like that's up to y'all, and we wouldn't necessarily rule one thing out or another. I can just say as a judge, I read a lot of applications of people who had very good ideas, but didn't know how to do the thing. It was clear they didn't know how to do the thing they were proposing. So like, why would we give someone hundreds of thousands of dollars to do that? That we're gonna prioritize people who know what they're doing, which is why we're doing, like one of the reasons we're doing this hackathon, because like what a great way to bring together people who know what they're doing. Yes.
So I'm from Chop, and then does Meta allow for any negotiation on terms and conditions? Because like my hospital needs some of like information about to like submit for the.
Yeah. So the question was about negotiating terms and conditions. I'd say probably not, but I do know that like, and I'm sorry I don't have this email address on the slide. It may even be in my deck. If there are questions from your institutions about the terms, like we can absolutely help answer that. And that's also something that I want to be a resource to you if I can like help answer those specific questions, but I wouldn't consider that like necessarily negotiating it.
How quickly is the response rate in the email? I think like we sent messages last week, so like we have to response.
Cool. Let's connect offline, and I can ask the team who's running that. And I see two more questions. I'll answer those, and I want to make sure that our my partner engineering colleagues have a chance. So I'll go you, and then we'll wrap up. Yes, sir. Well, especially for this hackathon, this is a great segue. I should have gone to you second, because our partner engineering colleagues are like flew in from California to support you all. We don't expect everyone to be an expert. That's another reason why we're doing this. So, well, I'll do better. I'll bring them on stage, and they'll be able to like, they've got a great briefing for you all, and I really appreciate them being here. And I appreciate your asking that question, because like we want this kind of learning here. And there's one more. Yeah, that is a very good question. I don't know if that's like one I can dive into like to the level of depth that it requires, but I think the short answer, and I'd be happy to like chat with anyone else in deeper terms on this. Meta has been open sourcing AI tools and our innovation for years. Like it's in our DNA. Our fundamental AI research lab, it used to be Facebook AI Research Lab, or FAIR. That's they just celebrated their 10-year anniversary about a year ago. So I guess they're at about 11 years now. So this is just a part of who we are. And that, like, in terms of open source, we've certainly benefited from it a lot, and we've built a lot of tools that we've then invested back into the open source community like PyTorch, because we learn and we grow so much better when the whole open source community is helping us build together. So it's like I think in those terms, it was just pretty clear that was an opportunity, and all the innovation that FAIR lab was doing, it's something that we've been really like proud to be able to continue to drive that, and we're seeing more and more. It's just much more in the spotlight now that there's like all this incredible progress around AI, but it's something we've been doing for a long, long time. Cool, good question. I'm gonna wrap up here. I'll be happy to chat with you in a moment, and I'll get that answer on the does this project today have to be your project for the grant application? I think the answer is yes, but I'm sorry I don't have certainty on that. And I'll hand off to my colleague, Randy. I hope you don't get a Mac update in the middle of your, like I.
Finger crossed. That's not good. Cool. Good morning, and thanks, John, for the details. And I think my name is Randy, and I'm a partner engineer at Meta for close to about 6.5 years now. So we flew in from Menlo Park. We also have Siam together with me today. Siam back there. So if you have any questions, technical questions related to Llama, we'll be happy to help you out. And there are some questions. Hey, you know, I don't know much about Llama or have limited knowledge. So that's the goal of the next 30 minutes. So to make sure that, hey, if you know less about Llama, after this session, you'll know more. And if you want to know more, you can try to use some of our latest tools. And if you have any other questions, we'll be happy to support you throughout the weekend. So a bit more context or details about like the various AI innovations at Meta. I mean, you guys are aware, hey, we have Llama. We open out the models. There are a lot of innovations out there. There are a lot of derivatives out there. But if you also use any of our apps, you also might have tried the Meta AI product or features in the family of apps. And you can try to generate image from that. They are pretty cool use cases. So those models are also powered by our latest and greatest Llama models. So how Meta is using the Llama models, one is on the open source path. We also use that internally to power our products. And the Meta AI is one example of that. And that is being powered by the latest like 405p model, which is like one of our biggest model, which I can deep dive more into it. And then another one is, of course, on the AI creation tools. If any of you guys use Instagram or Facebook, and when you want to create content, there are certain features there where we give you some superpower in terms of like creation capability, so then kind of enhance the way you create. So those are also powered by AI. So a brief history of the evolution of Llama, which if you see the timeline, is actually pretty impressive on how this space has grown in a very short period of time. So about a year and a half ago, February 23, is when we have the first version of Llama. And at that time, we don't know how the developer, how the communities will react to it, like what kind of use cases are there. So the very first iteration of Llama 1 is actually mostly for research purposes. So we want to see how like the researchers are actually using Llama and how they can actually adopt from it. And because of the traction of it, we quickly iterate over the years. And if you can see, almost after every like 3 to 4 months, we have like a new version of it. And that kind of signifies how fast the pace is in the development of the model itself. And just a couple of weeks ago, like about end of September, we released our latest Llama models, which is Llama 3.2. We're gonna deep dive a little bit more about like what is the latest offering in the Llama models. And also, we recently released what we call Llama Stack, which is the tools to actually allow you to build on Llama models and kind of speed things up. So how Meta is thinking about this is we're not just opening up the models, we're also trying to open source the tools and the capabilities around it so then you can actually speed up your development and building up cool applications out of it. So I think John shared some of the stats. So basically, pretty popular among the various models out there. And the cool thing about being an open model is that now anyone can build a derivative out of it. So what it means is, hey, as you guys are aware, the Meta models, the Llama models does support some languages, but not all languages, right? We have seen the community they fine-tune that and extend the capabilities to support other languages or like other more specialized use cases. So you can think of it, we give you the foundational models and any use cases that you want to build on top of it. If the foundational one is not enough, if you have good enough data set, you can fine-tune it and make it more specialized for use cases. So as a result of that, hey, there are like a lot of innovation out there on how these models are further developed in order to solve a more specialized use cases. So why Llama? Open approach, the Llama systems, which I'm gonna talk a little bit more about, like Llama Stack. We have Llama recipes to help you with all these different things. Trust and safety is also one important part of it. We released a bunch of safety Llama models. We call them Llama Guard. So you can actually use that to enhance and guardrails your system end to end. So for example, I mean, when you're building prototype, probably it's okay, right? Like you just want to prove your end-to-end use cases. But if you want to productionize it, you want to think about like how you can protect your system end to end. And we do have specialized models specifically for trust and safety that you can kind of utilize easily to further guard your prom and guardrail those results. So this is the Llama ecosystem. As you can see, all the popular cloud providers are there, probably the one that you have been using. So what we are trying to say here is, hey, we are not just releasing the model as is. We work closely with all these partners to make sure that, hey, regardless of the providers that you are using, regardless of the cloud solutions that you're using, we have the Llama models ready for you to adapt. So as part of the work from my team, every time when we release new models, we work with all these partners to make sure that, hey, you get the same level of model on day 0 when we launch it. The middle part of it is what we call Llama Stack, which is a new tool that we developed. So right now it's available on select partners, but we are also expanding more pretty soon, so you can kind of keep a lookout of it. Another important part on the bottom right is on the silicon partners. So in the latest Llama 3.2, we also released smaller models, which I can deep dive more into it. And that kind of unlocks a bit more interesting use cases for on-device models. And we work closely with those silicon partners, so then you can have an optimized inference solutions on device itself. So Llama 3.2, what is new, right? So the main key takeaway for Llama 3.2 is we released 2 parts. One is the smaller models. Small in a sense is still quite big, but not as big as like the cloud options, which is like the 1 billion and 3 billion models. So you can think of it, if you have use cases where you want to run things on device without any internet connection, the 1B and the 3B model will be a good enough options for you to consider. And we can deep dive into some strategy or architecture on how you should architect your system if you have like a more complex use cases. What we have seen in the market is that you can start with like a smaller models, and if that cannot fulfill your use cases, you can kind of do that in a bigger model. So you have like a kind of like an agentic architecture to kind of cater for different and more complex use cases. Another superpower that we released on Llama 3.2 is the vision capabilities, which means that previously up to Llama 3.1, we only have text to text, so input of text and then output of text. But 3.2 onwards, we have 2 versions of it, the 11B and the 90B vision model, which allows you to actually supply an image and then use that as part of your inference. And what is cool about that, then that unlocks a little bit more use cases on like image understanding. We have some OCR use cases that is pretty cool. So these are also some considerations that you can think about while you're building your use cases for the hackathons or even beyond. As you guys are aware, we have the base model and the instruct version of it. If you want to build like a conversation or like a chat-based kind of use cases, most probably you will want to use the instruct version. But if you want to fine-tune or like you want to do more complex use cases, then you can do it from the base model. So this is what I briefly talked about, which is the lightweight model, 1B and 3B. Context length is 128K. So these are what you want to consider if you want to build on device, which I can share with you more a bit later on. So these are just some landscape on why the smaller models is also important for Meta. As you can see, everyone has a smartphone. We also have our Quest devices, if you have tried them before, or even yesterday during the reception. So those are type of devices that can benefit from like a smaller model on device for like some very specialized use cases. So vision model, we have 2 versions, as I told you, 11B and 90B. So the general guidance is on on which size of the model to pick and choose, or at least my personal best practice is you should start with the smallest one possible. And then if that fits your use cases well, then that's good. Like smaller means faster, cheaper, and who want to pay more, right? And if it doesn't fit your use cases, then you grow to like a bigger size to see how that fits your use case. I mean, in prototyping, it's probably fine. Like you can use the bigger one, but while you're building like production use cases, that's usually how we think about how to pick and choose which model. So 3.1 is what we released, I think, 3 to 4 months ago. The main key takeaway is we released our largest model yet, which is the 405 billion parameter models. It's really huge, so most likely people cannot actually host it themselves. It's gonna be quite expensive, but what you can do with it if you want to try it out, there are like some cloud providers that actually host them for you to try out the use cases. And in fact, the Meta AI on our family of apps, they are actually powered by this, our largest model. Another important thing is the multilingual support. So for our Meta models, for our Llama models, we do support, I think, up to 8 languages here in the middle part of it. And I'll show you how, if your use cases actually entails on extending to a language that we don't support. So there are like some recipes on how you can further fine-tune the Llama models to extend its language capabilities. So the 405, I want to briefly talk about it. So we have seen how people are actually using this 405. I mean, while it's big and it's great, but it's quite expensive. But we have seen it to be useful for synthetic generation use cases. For example, let's say you are trying to fine-tune the 8 billion parameter models, right? You need some data to actually fine-tune it, right? So what happened is they actually use this 405B to actually generate synthetic data to help with fine-tuning. So you can think of it as like the larger model teaching the smaller model on how to be better. So these are also interesting use cases that we see how you can leverage the different variants of Llama models to kind of fit your use cases end-to-end. So that is the quick run course on Llama models. Now, what are the tools available, right? Let's say you want to build on Llama. I'm sure you guys have tried many different tools. There are many options, but these are some of the options for Llama-specific applications that you can try. As you are aware, cloud solutions, any of the popular ones, we have that supported. You can use that for the hackathon or even beyond. It's totally up to you, depending on your preference. Another interesting one is on-device. So on-device, we have this framework called Executorch. So Executorch is built by the same team that builds the PyTorch framework. So if you guys are not aware, PyTorch is also initially coming from Meta. We open sourced it, and now it's one of the most popular framework that you might have used. So Executorch is our solution, our framework for on-device inferencing. So there's a quick demo of it. This whole thing runs end-to-end in an airplane mode, so you can run inferencing on a 1B and 3B models without needing to use any internet connection. And what's the use case of this, right? I mean, while having good internet is great, but there will be some use cases where in rural areas or like when connectivity is not very accessible, you can have pretty cool use cases running on device, zero cost because everyone already owns the phone, and do some interesting use case out of it. Check them out, and if you have questions, we can talk more later. The next key resources that you should look out for is called Llama Recipe. So we have maintained this repo for like about 1.5 years now. So it's a collection of all the different best practices and also recipes on various different use cases that we have seen the industry needs and want. Like one good example would be, hey, I want to build a rack-based applications, but I don't know how. Well, great. We have a recipe for that, right? So you go to the rack section, and there's an end-to-end notebook example on how to run all this. So if you try and follow every single step, then in like 15 minutes or 30 minutes, you're like, okay, now I know how to do rack. And what I can do with it in your applications is totally up to you. And if, let's say, for example, you want to do fine-tuning, you don't know how, right? We have a recipe for fine-tuning. So that's also a good way to get started on the various different things. And even if you're not interested in some of the use cases, you can take a look at it and you say, hey, these are all the popular things, you know, that the industry is actually looking into and trying to try and all those things. So this can also give you some inspiration in case you are kind of thinking about what you want to build and how you want to build it. Another interesting tool that we recently released as part of the 3.2 release is what we call Llama Stack. Llama Stack is basically a framework or like an abstraction on top of the various different providers or options that you usually have when you are building your applications, but this is more specialized for Llama models. And you can think about it this way, right? So to build an end-to-end applications, probably you need an inference solution, right? You can use whichever that you want. You can use Together, you can use Fireworks, you can use Grok or whatsoever. And then when you have memory, you need like another service and all those kind of things, right? So basically, to build an end-to-end applications, you probably need like maybe 5 to 6 different tools or frameworks combined, right? So think of Llama Stack as the glue together to kind of combine all these things. And once the benefit of it is that because of the abstraction layer that we provide, then anytime you want to change to a different providers, anytime you want to change to a different options, you don't have to rewrite your application layer of stack. Because of that standardized layer, then for example, let's say today I want to use provider A for my inference solution, right? Each of them have different endpoints and different specifications. But 6 months down the road, I want to change it to provider B. You don't have to rewrite your application stack, right? You just change the config file. The Llama stack itself will take care and regenerate the new config for you, and then you will be good to go with minimal modification. So that's kind of like the vision out of it. And Llama stack is also fully open source, so you can kind of contribute. And if you see, oh, there are gaps, I like this provider, but it's not there, well, we are working with many providers in parallel, but if you have some expertise and you want to contribute, it's open source, so you can put out a PR. I'll be happy to kind of review and lend on those. So that's some of the available partners that we have up to date for Llama Stack, but we can dive more into that. So this is, okay, the table is quite small, but if you scan the QR code, if you go to the website, it will give you the options, like a table view of like what are available and what features are there. So that can kind of give you some understanding on which options you want to use for the hackathon. And I think, as John mentioned, we have like a specialized price for any solutions that are building on Llama Stack, specifically on tooling, or like if you have some interesting use cases out of it. So the price is $1,000 for any teams that builds on Llama Stack. Leverage the tools, or if you want to improve the tools, or you have use cases from the tool, that's a pretty interesting way to kind of try it out. And of course, we are rapidly building off this, so if you have feedback, issues, like give it to us, raise an issue, we'll be happy to kind of look into it more. I have another 10 minutes, so I'm gonna go through some examples on where you should go if you want to learn more about Llama Stack and Llama Recipes. So Llama Recipe, you just search Llama Recipes, and these are all the different use cases that are available, but I would want to point more on the quick start part. So you see, if you want to build a rack, you want to build agents, fine-tuning, images, inferencing, all of those, they have different recipes for like different things. You can just pick and choose, run them, and you'll have some understanding of that. The next part is the Llama Stack. So how to navigate to this is pretty easy. So you go to Llama Stack, you go to Docs, and we have this 0 to hero guide. This should be your starting point if you want to learn a little bit more about Llama Stack. Basically, Llama Stack has 2 components. One is the server side, and the other one is the client. So the client, we have Python, we have Node, we have iOS, Android, you can pick and choose. The server is where we standardize all the different interface on how the client communicates. So nothing is magic there. So basically the server, once it's up and running, will expose a bunch of REST endpoints that the client can communicate in a standardized way. And we abstract out all the different provider combinations on the server side, so then you don't have to change how you interact with different providers all the time. So the guide here is using Llama, but you can use whichever you want. For example, let's say you wanna spin up a 3 billion parameter model, right? So Llama 3.2 3B, which is small enough that you can run on your Mac or like local devices. So you spin up an Llama instance, you run them, and then ChromaDB is for the vector DB storage, and then you just pip install Llama Stack. This is our latest version. I think as of yesterday, it's like 0.0.54, but you just pip install Llama Stack, you should get the latest version. That should be good enough for you to get started. And once you have the server running, then you are pretty much set on the first part of it. Then if you're building on Python, you get a Python client, and then we have this different options for you to do different things. For example, inferencing, right, which is most likely what we want to do first as the first step. So the concept is pretty similar. You spin up a client, you construct your message, your prompt, and you get your response, as simple as that. And this interface doesn't change, so if you change to different model, different providers, it's all gonna be the same interface on the application layer. We also support streaming and conversation history, which is pretty standard, so I won't go through too deep about that, and you can kind of read it by yourself later on. Another cool thing is you can also instantiate different Llama Stack server instance for like different use cases or different models. So think of it, if you have like a more complex workflow that you want to run certain part of your flow using the 3B model and then the other one using 70B, some is local, some is cloud. So we kind of extract it in a way that you can kind of do that pretty easily by spinning up different instances for different use cases. And then prompt engineering, this is pretty basic. So we have like one shot, few shot. If you want a few shot, you just need to give some examples on how it should respond, and you will get better results because of the few shot prompting. The interesting part is the image chat, which is like the latest that we have on 3.2 now because it supports images. So the only key difference or the key trick is you need to encode your image. That's how it is being parsed in. So basically we provide you with the helper method to do that. You don't have to rewrite all this. Basically just give us your URL. It will turn out an encoded data of it, and then you just pass it to your model. Basically as simple as that. So you can try out image inferencing with minimal amount of work. Tool calling is also pretty interesting. As you guys know, there's just that much on how a model can do, but if you can kind of supercharge its capability with various tool callings, you can kind of do whatever you want, right? Like by default, we support some of the default tools. For example, there's like a Brave Search, there's like a Wolfram Alpha, but that's not the only thing that you can do. We also support custom tools calling, so which means that you can define your own parameters, you can define your own tool calling experience, and you just need to craft it in a way that the model can give you the right parameters and the right tool to call. And then, of course, you'll be offloaded to call whatever tool you want. So in that sense, you're not limited to the type of tools that we support, but we built it in a way that you can kind of extend it into any custom tools that you want. So basically, all the step is going through that. Try them out. Any questions? Happy to talk more later. Memory is also an interesting part. That's now in the setup. We set up the ChromaDB. So basically, that's for that. And it's nothing but a way for you to store all your embeddings so then you can actually query them again into your inferencing, right? So think of it in a simple term. You need a database to store some of your embeddings, like images, text, or whatsoever. And then in order to enhance your inference result, before actually calling the inference call, you query your database, your ChromaDB, or whatsoever solutions you want, and then it will actually give you a bunch of relevant results with scoring. So, okay, this is too small, but basically think of it. You query your database, give you a bunch of results with scores. It's up to you how you want to pick the top 5, top 3. You have some threshold, it's totally fine. And then that could be kind of enhanced and used together with your prompt to get better results. Safety, as I mentioned, we also support this. We have the Llama Guard models to actually do this. Agentic is nothing but putting everything together, as I told you. So if you are building some interesting use cases, think of what you want to achieve and how you can achieve it. Like, do I need to do tool calling? Do I need like a memory storage? Which model do I need to use? Is it just one model? Do I need 2 models? You know, how do I orchestrate all this? So once you put everything together, then you kind of have like an agentic flow end-to-end for your use cases. So that's that. And then before I take some questions, these are also some of the interesting insights. Okay, not sharing. Okay, sorry. Slideshow. So as I think John briefly mentioned about that, but basically AI and open source approach has not been new for Meta. We have been doing that for very long. A lot of our research has also been open source, so it can benefit like the community. I think how Meta thinks about this is, hey, if we open it, there's like a collaborative innovations. Maybe Meta will also learn from what the developers are doing. Like one good example would be language support. Like, hey, of course we want to support like 200 different languages, but we just have limited time and resources to do that. But once we open source it, the different communities fine-tune them for different languages, and now it can benefit a lot more use cases, right? Like, because not everyone speaks English, and there are some specialized or more nuanced localized language that even we don't have the expertise, but you guys do. So these are like kind of an example of why by open sourcing some of this, they will definitely benefit the community as a whole. This is also an interesting, it's a PDF that you can download, 30 pages, pretty long, but it kind of give you the TLDR summary of the various best practices that Meta has figured out over the years. For example, let's say you want to do fine tuning, right? How do you prepare and how do you find the data set in a responsible way? If you want to do B, do C, and do different things, these are all the different best practices that we have put together that you can leverage as you're thinking on building your applications end-to-end using Llama. Okay, let me put it back. Okay, cool. We have maybe a few minutes. Questions, thoughts, comments? Yes. We do have some support on Llama Stack, but we'd love to understand any specialized use cases that is not yet supported. Yeah, it's okay. Like, there's no restrictions on you must use only Llama tools. I think the philosophy is that the tools are there to help you build your use cases. But if your use cases requires a more specialized framework that Llama Stack doesn't offer yet, hey, put out an issue or request. We'll be happy to work with you to support that. And in the meantime, you can figure out and use whatever tools you want that fit your needs. Sorry? Yes. Yes. So in the Zero to Hero guide, if you go under memory, there's an example on how you can do that. Yep.
Folks, we have time for one more question.
Yes. So Llama also have the quantized version that you can run. Yes, I mean, you can use Grok and whichever providers you want. I think that's totally optional and up to you. I think for official Llama stack support, I think it's not there yet, but we are closely working with Grok to have that available. But you can pick and choose different combinations that fits your needs.
Randy, I've got one answer to the question that I couldn't answer before, and then we'll hand off. Can we give Randy a round of applause? Cool. Thanks, everyone. We really appreciate Cerebral Valley giving us so much time to share today. My only update is I got an answer to the question I couldn't answer before. So the question about whether or not your project for this hackathon is required if you're going to apply for the grants, it is not required. You can apply for the grant with a different project. We just encourage you to use it if you've already put the work into it with the hackathon, but not required. And I'm happy to talk if anyone has follow-on questions on that. Sorry I couldn't get that to you earlier. And with that, I'll hand off to Ivan.
Thank you, John. Let's give him a round of applause. We have a few sponsor workshops coming up, and then we'll get ready to hacking. First up, we have Akash Networks, who will be giving out compute at today's event. Please welcome Akash.
Hello. Hope everyone can hear me okay. All right, so first off, thanks for coming and thanks for letting us co-host this event with you guys. So my name is Anil and I lead product at Overclock Labs. Overclock Labs is basically the company behind the open source project that is Akash Network that I'll talk about today. With me is a few other people from our team. There's about 4 of us or 5 of us here. And we're happy to take questions afterwards as well. But what I wanted to do today was, just generally provide a general overview of what Akash is for people that are not familiar with it, and then show a demo of deploying Llama models on Akash. So before I get into my presentation, I would love to understand if anyone here has heard about Akash before you looked at the event page. So if you know about Akash, raise your hand. So I think I see like 3 hands up, so that's awesome. Okay, so I guess I'll spend about probably half the time that I have talking about what Akash is, meaning why does Akash exist, why was it built, and how does it work at a high level. And then I'll spend maybe the remaining half showing a demo of how to use it. So to start with, to understand what Akash is, it'll make sense to actually talk about what cloud providers are like today and why Akash is different from them and in what ways. So to start with that, hopefully that's clear. If you look at public clouds today, for some reason this is getting cut off. Let me see. Okay, it's better. Okay, so if you think about public clouds today, right? Typically, the way public clouds operate, most people here should be familiar with them, but you have a single entity like AWS that owns all the infrastructure, meaning all the servers that you deploy on. And then you as a user connect to that. So regardless of where you are, you're connecting to a single service provider. This has been extremely innovative and disruptive over the last 15 years, obviously. And that's because it's basically reduced or eliminated the barrier to entry for many small startups. So if you think back to probably 20 years ago, before the cloud existed, if you as a team of 2 or 3 people, like many of you probably here are, you wanted to get started on building something, you had to go find a data center where you could host your own servers, and then you'd have to pay a huge amount of cost up front in order to get started. And so that reduced the number of startups that could go and build and compete with larger players in the market. And then the cloud has completely changed that over the last 20 years, so it's been an amazingly good model for that. So then the question is, if I'm teeing up this slide, I'm obviously going to talk about why Akash is reimagining this. And so the question is, why bother reimagining it? And so there's sort of 2 reasons that I want you to take away from this. The first is, while most people in the world know about the big public clouds, most people don't realize that there's a huge number of data centers in the world today that are not part of the big clouds. So these are all independent data centers that exist in various parts of the world. And depending on where you get your data from, the numbers of these small data centers are anywhere in the hundreds to the thousands, and they're pretty much in every part of the world. And what's interesting is that most of these data centers, on average, they only have about 20% of their compute capacity that is fully utilized. And so the remaining 80% goes unutilized or underutilized on a daily basis. And so if there was a solution that could actually bring all that unused capacity and make it available to people, then we think there's a potential opportunity on both sides of that equation to bring some value. So that's sort of number one. And then the second thing, which is probably the more relevant one here, is in the last few years, there's obviously been a huge explosion in the number of people building AI applications. And if you think about a typical AI application today, what it does require is running something called accelerated compute, which is basically specialized compute that can do extremely fast matrix multiplications of really large sizes, right? And if you think about what is the company that builds them, there's basically one company called NVIDIA that builds most of the compute capacity that does accelerated compute today. And so what happens as a result of that is there's a huge supply crunch. And most of the cloud providers today get an allocation from NVIDIA whenever there's a new chip that comes out. And so what happens in that situation is that the cloud providers become somewhat selective as to who they provide the latest and greatest GPUs to. And then if you want to go and get GPU capacity from the cloud providers, you typically have to commit to a fairly large spend with them, right? So this, again, is kind of killing the cloud model, because now you're back to the old days where if you're a startup of 2 or 3 people, you've got to commit to a huge amount of spend up front in order to get access to these GPUs. And so these are some of the problems that Akash hopes to solve. And the way we do it is through something called a decentralized approach. So essentially what Akash does is it separates out the data plane from the control plane and implements essentially a distributed or a decentralized control plane that looks something like this. So what you have here is essentially a two-sided marketplace. On the one side is what we call compute providers. So those provider 1 through provider n, those are individual providers on the network. Think of these as little tiny data centers located in various parts of the world. There's about 70 of these on the network right now and growing pretty rapidly. And each of these compute providers essentially provides all sorts of compute, whether it be regular compute or accelerated compute, namely GPUs. And then on the other side of this equation is users, which is anybody in the audience here or anybody that wants to run an application. And so users come to this marketplace, and what Akash does is it implements a software layer between these providers and the users and provides the abstraction of a cloud service to anybody that wants to use it. So what that means is regardless of whether you're deploying onto provider 1 or provider 2 or provider 3, you get the same cohesive experience that you get from a public cloud. And so that's the general idea with Akash. So then the question is like, what benefits do you get from this? So the first obvious benefit is that you have as the network grows, you have a large number of providers across the world, and so you get a huge amount of choice in terms of where you can deploy, as well as the type of data center that you can choose. But then the bigger benefit is because this is a two-sided marketplace, similar to something like Uber or Airbnb, it essentially creates competitive dynamics between these different compute providers. And so as a result of that, what you end up getting is end up getting extremely competitive pricing for both CPUs as well as GPUs, right? So if you go to that link there, akash.network/GPUs, you'll basically find a calculator as well as a real-time update on all the costs of various types of compute on the network right now. On the left, you can see you can go and actually configure the requirements that you might have for an instance you may be running in AWS or GCP or Azure. And what you'll find is that on Akash, it'll on average be about 30 to 40% cheaper. And then on the GPU compute side, something like an H100, which is probably the most in-demand GPU right now for running large language models, you can get that for as low as, this slide is actually a little bit out of date, but as low as 99 cents an hour. And this is on demand, by the way. So just to compare and contrast that with AWS, if you haven't gone and checked out instances on AWS, you'd have to probably pay about $3 or $4 at minimum, and you'd probably have to commit to like 3 or 4 months of spend on them. So that's just some of the benefits that you get from using a service that is creating essentially a marketplace. So outside of that, there's a couple of other things that are very unique to Akash that I think are very relevant to this audience. We're talking about open source software. So I think, as far as I know, and correct me if I'm wrong on this, but Akash is the only cloud service that I know of that is completely open source. So on the left here is our GitHub repo. You can go to it. It's github/akash-network. All of our source code is open out there. And then, of course, we use Kubernetes and Docker underneath. And then we also follow an open development model. So literally, all of the work that we do is documented in the open, very similar to the Kubernetes project. So you can pretty much follow that in GitHub as well. So just talking quickly about how a typical deployment workflow looks like in Akash, looking from the left and going towards the right here. You as a user bring your application, you containerize it into a Docker container, and then you write something called an SDL file, which is a stack definition language file. It's basically telling Akash, this is what my compute needs are for my service. And then you submit that to Akash, and then what Akash software does is it sends it out to all the providers on the network. So every single one of the 70 providers receives the specification, and then the provider looks at it and says, hey, can I honor this request or not? Can I meet these requirements or not? And if it can, then it responds back with a bid. And so what you get back is a whole bunch of bids. And then you pick the bid that works for you based on price, based on location, based on the uptime of the provider, many attributes. And then if it looks good to you, you click a button and your application gets deployed. This seems like a pretty complex workflow, but it only takes a few seconds. And I'll demonstrate that to you. I talked about the SDL file structure, SDL file. So that's the SDL file structure. It's very similar to a Docker Compose file, if you're familiar with that. To break down what it is it's basically got 4 or 5 different parts to it. what service are you running, which is typically indicated by the container image, what resources do you need, how much are you willing to pay for it, and how many replicas do you need. Okay, so I'll jump into a quick demo of all of this. So switching over to the other side here. So what I have here is Akash console. Hopefully that is visible, yep. Okay, so first off, if I click on providers here, and by the way, you can go to console.akash.network and check this out yourself as well. There's a total of 70 providers on the network. Each dot here is, think of this as a little tiny data center located somewhere in the world. Below here is all the aggregated compute capacity, and below that is compute capacity per provider. So I'll click on deploy here, and what you'll find is, I'll go through some of these other ones first, but first off, your eyes probably went to the Llama tiles up here. And so what these are is they're basically pre-canned templates that we have created for deploying Llama 3.1, 8 billion parameter model 405B, FP8, as well as 405B, FP16, BF16. So that's the 8-bit quantized and 16-bit quantized versions of it. So what I'm going to do now is I'm going to basically deploy the 8-bit, the 8 billion parameter model of Llama 3.1. As was suggested by the person before me, it's better to go with a smaller model to start with, so I'm going to pick that one. It should take a few minutes to load up, but as you can see now, here is the SDL file that I was talking about. What I have here is I'm using something called VLLM, which is a framework for running large language models like Llama, and it takes care of everything, including providing a super high throughput interface, as well as taking care of providing an API server. So I've got that, I've got my command line arguments here, and then I've got the compute resources that I need. In this case, I'm asking for a single GPU and ideally an H100, A100, and RTX 6000 down here. So I'm just going to go ahead and click on, before I do that, actually, first I'm going to go grab my Hugging Face token from here. So here is the Hugging Face token that will be used to download the model. So I'm going to go there, put that token in there, and then just click on Create Deployment. So what it's doing now, it's saying I'm going to go ahead and deploy this on a, I'm going to try to find a provider that has 1 GPU, 12 CPUs, 32 gigabytes of RAM, and 50 gigabytes of storage. So confirm that. What's going to happen now is Akash is basically going to take your request, which is that SDL file there, and it's going to broadcast this across the network to all those 70 providers. So every single one of those 70 providers is going to receive that request, and if they can meet the requirements, they're going to respond back with a bid. So what you should get back is a few bids, and then as we're waiting, it's looking for even more bids. So you can see here, there's 3 providers here with NVIDIA H100s on them. So I'm just going to go ahead and pick one of these here. So I'm just going to pick this last one down here, accept bid. So what's happening now is I've said, okay, I want to go ahead and deploy onto this provider. So it's going to create something called a lease between me and this provider, and then it's going to deploy my application out here. So what you'll see now in a few seconds is logs coming back from that specific workload coming up. So here we go. So this is events from that provider, and then if I click on logs here, you'll start to see logs coming up. While this is going, what I'm going to do is jump back to the deploy page here and talk about a couple of other things. So there's similar templates to this for all sorts of things here. But then if you want to run something custom, let's say you want to build your own custom container and deploy it, you can do that using this option here. So you come in here, and you can just basically paste in your custom container image. Your container image can be sitting inside a private registry or in a public registry like Docker Hub. And then if you don't, if you're somebody that is not container native, meaning you're used to running, just grabbing a VM from EC2 or GCP and working with it, then you can just go and use this option here, which will let you basically get a container VM, and then you can SSH into the VM and download whatever you want to it. And then this last option here is for people that don't want to worry about infrastructure at all. So if you're a pure web developer who's used to using something like Vercel, where you just go and you say, hey, here's my React app, here is the GitHub repository that has the React app, and go ahead and deploy this for me and just give me an endpoint, then this build and deploy option is for you. So you can just go in there, connect your GitHub repository, and then it'll just build your app for you. Okay, so let's go and see how our deployment is doing. So this is the new deployment that I just deployed. This is a previous deployment I did in case we have issues today. So I'm just going to go back here and look at the logs. And so you can see now that it's basically loaded the model, and it's saying that it has an endpoint for me. So I'm going to go ahead and click on leases here, click on this endpoint. And so what's happened now is that the provider has actually deployed my endpoint here. I'm just going to grab this URL here. And then what I'm going to do is I'm going to basically put this in a basically a HTTP post request that'll essentially submit a prompt to this model that I deployed. So that's the same URL that I just deployed. And what I'm doing is I'm going to basically use that to prompt it. I'm going to go back here and paste that. And I'm just going to ask it, what is Austin, Texas famous for? And let's see if that works. But that's basically how easy it is to deploy something onto Akash. And then just to wrap up really quickly, here's some of the people that are using Akash today, just a few of them. There's a lot more names that we could put on the slide. But few to call out here. News Research is a team that builds new models as well, or they fine-tune models based on other open source models. Venice AI is running a chatbot that is privacy preserving. And then brev.dev, which technically now is part of NVIDIA, has a platform for doing all sorts of fine-tuning of various open source models. And then, of course, local to Austin is a team at UT Austin. So we work with a research team led by a professor at UT Austin, and they are using Akash for research as well. Last slide, if you want to engage with us, like I said, there's 5 of us here, Zach, Amanda from marketing, and then Arthur in the corner there from engineering. And then all of us are going to be sticking around today and tomorrow here. So if you have any questions, please come up and ask us any questions that you might have. We also have a Discord server, and then you can hit me up on email as well. So my email is out there. And that's about it for today. Thank you, everyone.
Thank you. All right, next up we have DataStax.
Yeah, thanks. Uh-oh. All right. It is great to see everybody. Hey, my name is Carter Rabasa. I'm a developer relations engineer at DataStax. I think I'm kind of standing between everybody and maybe kicking off the hackathon. So I'm going to try and go through this as fast as I humanly can. I'm happy to be back in Austin. I graduated from the Macomb School of Business back in 2009, hook 'em. And like I said, I work at DataStax. So what is DataStax? I think for the purposes of this hackathon, this should be really happy news. DataStax is an insanely fast way to build AI applications and get them deployed. So it's like perfect for hackathons. Can I see a show of hands? Who here knows what a vector database is? Fantastic, we have one. Who here knows what LangChain is? Fantastic. We've got something built on top of LangChain. I'm going to show it to you in just a second. So I want to talk a little bit about RAG. I have a feeling that most of you know what RAG is, but for those of you who don't, RAG is a way of dealing with something like this. This is LangFlow. LangFlow is a completely open source visual AI editor built on top of LangChain. And here is a demonstration of why you need RAG. So I've wired this up. I'm using a Llama. I've wired this up to Llama 3.2, and I'm going to ask it, what is the current price of Meta? All right, out of space. We all know what's going to happen. The model is going to be like, I don't know because I was trained in the past. And that's just a classic example of what you can use RAG for. Now, while this is thinking, some of you here might be machine learning engineers, and you might be incredibly comfortable with the idea of training or retraining models. And you might object to me and say like, aha, I can solve that problem myself by retraining these models. Yeah, fair, you don't need RAG. I'm a web developer, so if you are a full stack web developer, you are not a machine learning engineer, RAG is a wonderful technique for achieving the exact same thing using pretty standard web development skills. This is AstraDB. AstraDB is our cloud-based vector database. All of you can sign up for it completely for free. We will not even ask you for a credit card. This is what Astra looks like. It's kind of very MongoDB-ish. You create a database. You can create one or more collections within the database, and then you can create documents. These are a bunch of documents. This is a movies database, like 1,000 of the top movies from IMDb. Every document can contain metadata. It's just JSON, right? So this is kind of what these things look like. But they can also contain vectors, which look something like this. Huge, scary piles of numbers that ultimately represent the meaning of what you have run through the embedding model. I actually didn't know that Meta had an embedding endpoint. I'm going to learn more about that. These embeddings were generated using NVIDIA. So when you create a database and collection, if you want to, you can use any embedding provider you want. But out of the box, we come built in with NVIDIA and their NV Embed QA model. So all you do as a developer is you just call a RESTful API, you send us some data, we'll vectorize it for you, no muss, no fuss. So now that you have information in a vector database, you can do cool things. So this is a movies database. I'm going to search for, let's see, movies with big, scary monsters. Now, I know that that's plain text, and I'm sorry it's so small. Let me zoom in, right? This is plain text, but because I've attached NVIDIA's embedding model to my collection, this is actually being converted into a vector under the hood, and then we're executing vector search to get back a list of results in reverse order of similarity score. So we can go over here, and we can see Terrifier, Monsters, Inc., Creepshow, Megaboa, Predator, so on and so forth. So as a developer, you know how this is. Like, if you're not happy with the kind of results you're seeing, you might want to try use different embedding models. If you're not happy with the performance of the AI application you're building, you might want to try different LLMs. So now that I've built this, I'm going to go ahead and go back to Langflow. Langflow is, as I mentioned, totally open source, completely free. You can pip install it. We do have a cloud-hosted version for you if you just want to get up and started super fast. And this is what it looks like to execute RAG inside of Langflow. I can easily zoom in and zoom out. This is just going to be an example of me giving it the exact same prompt that I gave it inside the database. We're going to execute the exact same vector search using AstroDB. We're then going to take those results and use them to construct a prompt. I'm sure many of you are kind of familiar with prompt engineering. We're then going to pass that prompt to Grok in order to use one of the Llama models, in this case, Llama 321B. And then we're going to pass the output out. So let me go ahead, and I'm going to ask the exact same thing. Movies with big monsters. It's going to think about it, and this is not like a cloppable moment. It's just going to give me the exact same thing I saw before. But what matters for you, because this is a hackathon and you're building applications, once you have built your flow, once you're happy with the results that you're getting, like how do you get it out, right? How do you sort of wrap this into something that's an actual app? Well, we have an incredibly easy to use HTTP API. You call this endpoint and you get the data back. And over here, I have an example app that I just built using Next.js. I'm going to run the exact same query, and to no one's surprise, it's going to return back the exact same textual data that you saw before. But one thing that I think is pretty cool, especially for folks that are trying to build intelligent software, like intelligent UX, smarter applications, is the opportunity to use generative UI. So I'm going to go ahead and just ask my app to show me this as UI. And I'm going to go ahead and do that. And this is under the scenes. This is using something called Vercel's AI SDK. And then boom. It's my application understood what I was asking. It has now generated this as fully interactive UI. I can go ahead and click on any one of these things, open up a page. And honestly, like when you start to think about generative UI, like the sky is kind of unlimited. How about can I see the trailer for, I don't know, King Kong? See what happens. Think about it. and then presto, trailer. Now, this is a bit contrived, right? But I mean, in the actual applications that you're building, like, try to, get out of the box, right? A lot of users, like, don't necessarily want to engage with software as chatbots, but there are smarter ways that you can give them more natural experiences. The last thing I wanted to show you is agents. So I think I think you mentioned tool calling, right? There's a lot of words for it. Tool calling, agents. So Langflow recently released a 1.1 update that added some really awesome agentic capabilities that I will very rapidly demonstrate for you. So here's Langflow. Here is an agent. It's got this little purple robot icon. I have it wired up to Grok, and importantly, I have it wired up to a tool called the Yahoo Finance tool. So in Langflow, there's a ton of tools, and in fact, there's actually an easy way. And by the way, I know sometimes developers are really like irritated with GUIs. I know I feel that way. Just so you're super comfortable, this is all Python behind the hood. It's all Python. This is just like I don't know, just think of this as like a really fast and easy way to bootstrap things. But under the hood, it's Python, it's LangChain, it's all the stuff that you're familiar with. So cool. So I've got this wired up to Yahoo Finance. I'm now going to go ahead and I don't know. I'm going to say like, what's the thing that failed before? Like, what's the current? Current price of Meta. Awesome. And demo guides. It's telling me that it's executing the Yahoo Finance app. And of course it failed when I did it here. Let's see. Why don't I try that over here? All right. I'm gonna go back here. And simple agent. I had this wired up the same way. I'm sure I just made a mistake, but let's try it twice and see if it's nice. What's the current price of Meta? All right. Fantastic. Boom. Okay, that's applause worthy, folks. One thing that's really fun and great about, and this is new for Langflow 1.1, there's just a ton of debugging. So you can expand this. You can see exactly like, what did the human input, like what did the tool output. You know how it is at a hackathon, right? Like you're trying to do something, it's not working, you're freaking out, like why isn't it working? The debugging capabilities of Langflow have really improved. So I think that's it. So why should you use this stuff? Well, you should use it because it's awesome. But you can also win a prize. So the best use of DataStax is going to win this looking glass display. I wish I had it here in person to show it to you. It's absolutely magical. Like it legitimately creates these completely realistic 3D holograms, and you can load it with your own photos and videos. It's just absolutely stunning. Whoever does the best use of DataStax, and which can include either AstraDB or Langflow or both. We are going to mail you one of these things, and you're going to love it. And I guess I'll just close with this. First of all, so once again, my name is Carter. My colleague Nadir is here. Nadir is actually the head of engineering for Langflow. We're going to be here all weekend. Our only job is to help you build stuff. Quite frankly, like, I would love for you to come talk to us about how to build on our products. But hey, look, like if you have any questions in general, like we're happy to help, right? You have some Python questions, you've got some like JavaScript questions, Next.js questions. Like I've got nothing else to do but help you all be successful. And yeah, this QR code and that URL are going to send you to a little Notion page with just a bunch of resources, like links to the docs, like some YouTube videos that might help you get started. And that is it for me. I guess I'm going to turn it over to our fine friends from Cerebral Valley. But thanks so much for having me, and I can't wait to see what you all build.
Thank you, DataStax. All right, folks, I got a few final logistics announcements, and then we'll get started on the hacking. Let me hook up my laptop. All right, well, my laptop is dead. I'll do this offhand. I'll put up a QR code later, but essentially, in terms of the schedule, this was kind of the kickoff. We will be moving up to the 5th floor. There's a massive co-working space up there with a bunch of seating. There will be sponsor booths around from DataStax, from Akash, from Grok, from Meta. So you will be able to come up and chat with those folks as well. In terms of the prizes, so we have first, second, and third place for just the general hackathon. And the way that's going to work is we have a few prizes here. We have a Tesla Cyberquad that we brought out. It's pretty cool, right? We have a Meta RayBans, and then we have a DJI RoboMaster S1. That's like a programmable robot. Super cool. So those are the 3 main prizes. But as a reminder, the 2 tracks that we have are like Austin Impact and open source developer tooling. For the Austin Impact specifically, we also bought a cowboy hat from Tecovas. Apparently it's a great store around here, so we'll be giving that out, and then $1,000 for the Llama Stack, Best Use of Llama Stack prize. As a reminder, DataStax is offering a prize as well for Best Use of DataStax, and then Grok is offering $500 to their swag store. You're going to see their sweatshirts. They're really super cool. So $500 for best use of Grok. The way you will submit your projects is in that Notion doc that I'll send out in the Discord. I'll also put up a QR code here while we're here for a sec. In that Notion doc, there's a project submission form that you'll just fill out, pick out what tools you used. There's also like a Meta Llama survey as well. And that will be submitted by noon tomorrow. And at noon tomorrow, we'll start kind of the first round judging process upstairs. And then we'll come out for the final project presentations down here. Let me know if you have any questions, but at this moment, we will start kind of gathering everyone and moving to the 5th floor. The elevators are in the back over there, and we'll just hit that number 5 button and then go upstairs to floor 5. Thank you so much, folks.